The National Ecological Observatory Network, otherwise known as NEON, is designed to capture and provide a wealth of data, free data open to the public. We are here in Pu'umakala Natural Area Reserve on the island of Hawaii, and this is the very last site of the entire NEON network. There are 81 terrestrial and aquatic sites, and we're the last one. The idea of NEON is to create this giant data clearinghouse where anybody, the public, can go on to the NEON website, access all the data from Hawaii, all the data from Alaska, from Puerto Rico, from Virginia, so they can see continental scale changes over the course of the 30 years of the project. It's also available to student groups, to researchers, really to kind of excite people about science and the type of measurements and the type of data that we can collect and how it connects to the changes that they see around them. That's a huge benefit to the National Ecological Observatory Network, is that there is guaranteed standardized protocols to measure everything. Here in Hawaii is the exact same that's being measured across the nation. It's a 30-year project funded by the National Science Foundation, and there is no other observatory network quite like NEON. The idea was to make this huge network so it is freely available to the public, because so many people do have questions about how is maybe rising temperatures going to affect the forest, and here we can provide a 30-year potential data set. How can these potential environmental changes affect invasive species, which is extremely important here in Hawaii.
We have a host of quite a few radiation sensors. That includes photoactive radiation sensors, or PAR sensors. We have net radiometers that talk about how much radiation is being downwelling as well as upwelling, so it gives you an idea of what's being absorbed. We have radiance, absolute radiance radiation sensors that tell you about how much light is actually making it through the clouds in the atmosphere. We also have different kinds of rain samplers that tell you about exactly how much rain is falling as well as what's inside the rain. We have a whole host of gas systems that measure how much carbon dioxide and water vapor is being transpired from the plants as well as coming down from the atmosphere.
So we've got the terrestrial tower instrument systems that you went over with Rob, and we've also got another component called the terrestrial observational system, which is what I'm heading here. And basically they're two sides of the same coin. You've got the instruments that take data at a much higher temporal scale, and then you've got the data that we observe on the ground that can basically be used to validate and even correlate with data you get from the tower. So in this case, we're looking at phenology. So plant phenology in particular. We're looking at the timing of flowering and leaf bud, leaf flush, those kinds of metrics on these plants here.
It's absolutely exciting to work in such a beautiful, beautiful forest, and we really try hard to protect this forest. We really care about the birds and the plants, and we understand the value and the importance of the data and the information that we can provide to the land managers. So one of the things that we're really excited about, and we really want to give back to the community, this is an incredible infrastructure that's been in place. I want to encourage involvement with K through 12 education, with higher education, college courses.